so I'm recording so that I can put this on YouTube. So I put this YouTube video is going to be long, but it's just recording me, so it's not recording you guys or chat. It's just me in the video, and that will be on YouTube later. So yes, the notes will be on Teams, especially if it's blurry. All right, so quadratics. Okay. And we have a couple forms, right? We're mostly going to be focused on standard form, which is f of x equals ax squared plus bx plus c. And then we have factored form. F of x equals a times x minus p, x minus q. And we talked about these both last chapter. Let me add some stuff. And we want to be able to switch between these, right? We want to be able to go from factored form to standard form and from standard form to factored form. We want to be able to do that. So how can we turn factored form into standard form? Well, we multiply. And we had two methods yesterday, not yesterday, Monday that we talked about. We talked about the area model. This is the box, right? And distribution. Man, these Sharpies have never been used before, I'm pretty sure, and they definitely smell very strong. Okay, let's get rid of that so you can see the arrow. Okay, so that's what we talked about on Monday. And that's what we did just now in the warm-up, right? So we multiplied parentheses and we turned it into some sort of standard form. Okay. Today, we are going to factor. And we're going to start with, there's going to be a list of things that we can add in here. There's going to be we're going to start with the Xbox method. There's going to be the area model. There's going to be the quadratic formula. And maybe some other ones that I'm forgetting. Okay. So we want to turn our standard form equation into factored form. So standard form equation into factored form. And let me know if I'm going too fast, and we'll move stuff around. Okay. So I'm going to move to a new piece of paper just so that this is kind of its own thing. But this is what we want to be able to do by the end of the chapter. Mostly because when it's in factored form, we can find the roots really quickly. P and Q here, which is what we did last chapter. If our goal is to solve quadratics, it's really easy to solve when it's in this form, because solving is just finding x when y is 0. So we want to be able to turn the function from this stuff into this stuff. We're doing the opposite of what we did on Monday, doing the inverse. All right, and we're going to start with the hard way. And goodness, I hope I remember how to do this. Uh-oh, should be fine. Oh no, it's pushing through the paper. All right, so factoring. Using the Xbox method. So unfortunately, we're in fourth period. This is the first time I'm teaching this. I'm probably going to get it wrong. I'm setting myself up that way because we'll see if I get it right. But lowering expectations, it's easier to step over them, right? So we start with standard form. Y equals ax squared plus bx plus c. And we're going to list out a, b, and c. So step one, so we would do a equals some number, b equals some number, c equals some number. These could be anything from 1, 0, fractions, right? So the first thing we're going to do is we're just going to list out the values of the function. My notification is just chat. Okay, cool. List out a, b, and c. And then we're going to make an x. So here's our x part. Draw an x. And the top of the x is going to be, I'm going to make a statement and hopefully I don't have to retract it. I'm pretty sure it's AC. So what numbers, we're going to multiply AC up here. So whatever those two numbers are, multiply them together, they go on the top of our x. Okay, and then the bottom is going to be b. So step 2, fill in this x. Very strange messages I'm getting. Okay, so from here, once you've multiplied those two, we're going to find two other numbers. These two numbers are going to multiply to make AC and add to make B. So M and M, we're going to need to do some like deductive reasoning. M times N is going to equal whatever AC is. And M plus N equals B. So step 2 is fill in the box. Step 3, find M and N. We're going to have to figure out what those are. It's not necessarily going to be the easiest thing to figure those numbers out. But what are two numbers that multiply to make AC and add to BB? I sure hope that that's right. We're going to try it, and then maybe I'll need to double check something. All right. Then step 4. Yeah, you've done this before, Lily. Yeah, you did this in Algebra 1. Step 4, fill in the box. The inside of the box. So I'm actually probably going to run out of room here, but just like we did with the area model where we multiplied the outside, now we're going to fill in the inside and figure out these pieces here. So those we don't know, but the inside of the box, we do know. So here, This number is going to be c from our original equation. So this piece goes here. Okay, and then ax squared goes there. And then in here, we found m, right? So mx, and then nx. So those two numbers that multiply to make ac and add to make b, those go inside our box. So we fill out the inside of the box. So we're doing the inverse of what we did on, here, I can move this up just a little. There's nothing under. I'm not covering up anything with my picture, but we're doing the opposite of what we did on Monday, where we know the inside of the box because we have standard form already. We know the inside. And so we're going to take that inside and we're going to have to figure out this outside piece. So step 5 then, I need another color. Step 5 I'll do over here. Oh, that is not what I was expecting. Let me find a better color than that. We can use red. So our 5th step is filling in the numbers. Man, that's really hard to read. We're going to fill in the numbers that multiply to make the box. So if our box is this thing, and we've got ax squared in here, we have mx, we have c, we have nx, we have to find the numbers that go here. So there's a number here, there's something here, there's something here, there's something here, and there's something there. We're filling in those things. Okay? Those are our steps. So we're going to do a bunch of examples now. We've got 30 minutes. We're just going to do it a bunch of times. Let me share in chat. Yeah. Yeah, sorry. Fill in the numbers that multiply to make the box. So on Monday, right, we knew these outside numbers. We multiply them to find these things inside. Now we're doing the opposite. We're taking these things inside and deducing what do these two numbers have to be to multiply to make this. We'll do some examples. It'll make more sense when we have actual numbers there. Let me find the link first I sent it to Paulina. Here we go. Wait, no, not that. This. Okay, so there's going to be a PDF. Sure hope this is the right PDF. And it's got a bunch of problems on it. Perfect. Okay, so this is in our Teams folder. And so we're going to use this document to use for examples and for probably homework. So it's probably going to be both. I haven't assigned it in Teams yet, but okay. So if you open that, you can see the problems and they look like, I wish this zoom button worked differently. They look like this. Okay. So we're going to factor trinomials. A quadratic is a trinomial. So don't get confused. That's not something weird. It's right. I can't show it on my paper. When we're looking at these quadratics, it has 1, 2, 3 terms. When we multiply binomials together, we get a trinomial. So now we're taking the trinomials and we're going to turn them into a pair of binomials. You don't need to call it that. We're just factoring a quadratic. Okay, so we're going to start with number 1 here, and we're going to do that one first. Okay, so that's the one I'm going to do as my example. So I'm going to go back to my paper. You should have that document open. And so this is example 1. Factor. What was the problem? 3p squared minus 2p minus 5. Okay. First step. Step 1. List out A, B, and C. So I'm going to do this in blue. I'm going to try and color code it like I did the rest of the notes. So A, B, and C. Well, A is the first number. This is 3. B is the second number. It's -2. Bring the negative. If you forget this negative number, if you make this a positive, you are not going to get the right factorization. So you need the negatives, and C is -5. Okay, so first step is just list out the A, B, and C values, the coefficients on the quadratic. Okay, and then we're going to fill in our x. So the top is A times C. So A times C is -15. And the bottom is -2. It's just B. I'm looking at this and I'm like, I did the notes right. We did this right. Great. Awesome. All right, so now we need to figure out what are these two numbers that multiply to make -15. And I would not write m times n out like this every single time. And they need to add to be -2. So I would not write this out like this every time. I would just fill in the x box, the x. So what are two numbers that multiply to make -15 and add to make -2? Now the creative thinking you're going to have to do here is remember negatives matter. Okay? So numbers that multiply to make 15 are like 1 and 15. Well, those aren't going to combine to make 2. And 3 and 5, which do combine to make 2 if we subtract. Right? So this is a 3, and this is a 5. One of them has to be negative, though, right? Because if we multiply two positive numbers, we don't get -15. And so when we add them, they need to add to be -2. So yes, Lindsay and Jose, that's perfectly correct. The 5 is going to be the negative because when we add these together, we need to get -2. And so the bigger one needs to be negative. Okay? So we know m and n. It doesn't matter which one's which. It doesn't actually matter. Like I could have written the -5 over here and the 3 over here. Which side is which does not change the problem at all. Okay, and now let's fill in our box. Does it matter what color I use? Not really. We're going to use red. So we know the inside of the box. We know the area of the area model, and we want to find the lengths of the sides. So on our previous lesson, we multiplied these outside side values to find the inside. And now we know the inside, and we need to figure out the outside. So the inside is going to be ax squared. So we're using p, not x, but it's 3p squared. And then this is -5, it's c. And then we fill in the m and the n. So this is going to be a 3 here and a -5. It doesn't matter where you put them. But I've forgotten something. These should have p's on them, or x's. So I filled in my box. Okay, so I have ax squared. This is from the problem here. I have the -5, also from the problem. And then the -5 and the 3 that I found from the x go with the single variables, because these two numbers combine to make this -2p. right? So now we just need to figure out these pieces. So what do they have in common? That's what we're asking. What does 3p squared and 3p have in common? What can I factor out of both of these? Well, they both have a 3 and they both have a p, right? What do these both have in common? Negative 5p and negative 5 both have a negative 5 in common. Okay, from there, once we have like one of these sides or even just one of the values, we can just figure out the other side by saying, okay, what do I need to multiply this 3p by to fill in this box? What times 3p gives us 3p squared? Well, a p. Yeah, Kyle. Yeah, p. What times 3p is going to give us 3p again? And what times negative 5 is going to give us negative 5? Well, this is just a 1. Okay? So we've deduced the outside of the box. We've done number 5. Oh, there's a 6th step that I forgot, but it's just writing the answer down. So our factorization is p plus 1, this thing, times this thing. And so that's our answer. We have turned standard form into factored form. And we are intentionally starting with the harder problems. So sometimes you don't need to do this x. You can just go straight to the box. And so we'll talk about that later. But I want to start with the hard ones and then get easier for this because I think that'll make us feel better about the unit, I think. Okay. This is a very methodical process. You follow the steps. You need to do some deduction to find these numbers and then to find the outside numbers once you've filled the box in. There's some deduction to do, but it's a very methodical process. What are two numbers that multiply to make the top of the x and add to make the bottom? And you have definitely done this in Algebra 1. Okay, so let's do another one. Hopefully you have enough room that you can see these instructions here. And actually, let's add in a step. Let's add in this 6th step. Write the factorization. And I'm sorry if you like ran out of room. And also that says factorization. Basically, we're writing the multiplication out. And I'm going to be very general here because we can't actually figure out what these numbers are. But it's going to be like number plus number times number plus number. It's whatever we found here, right? It goes inside these parentheses. All right. And if I'm going too fast, please let me know. And I'm going to repost it all. I'll post the pictures and I'll post the video too. Okay. Let's do, do I want to do number 2 on this PDF here? Let's do number 4. Okay. So I need another piece of paper because I'm just out of space. This is going to be number, this marker doesn't work. Number 4 from the PDF, which was 5n squared plus 19n plus 12. So we're going to factor that, turn that into factored form. Okay, so our first step is the easy one. List out A, B, and C. So A is something, B is something, C is something. And this is the reason that we listed out all A, B, and C last chapter when we were doing negative B over 2A. It's because we use C to do the Xbox method. So once we know those, well, then we fill in our X. So the top is going to be AC, the bottom is just B. So 60 and 19. Carlos, you got a question, or did you just accidentally unmute yourself? I don't know. Noisy. All right. So from there, we need two numbers that multiply to make 60 and add to be 19. I'm gonna be honest, I don't know off the top of my head. So what we can do is we can figure out, so m times n needs to equal 60. What are numbers that multiply to make 60? There's a lot. Let's see, 1 times 60. That's not going to be added. That's not going to add to make 19. We could do 2 times 30. That's not going to add or subtract to make 19. We could do 5 times 12. That's going to make a 17 or 7, right, if we add those. So that's not 19 either. 3 times 20. That makes 17 or 23. 5 times 4. Yes. Not 5 times 4. That's 20. 15 times 4. 4 times 15. Which does add to make 20. Right? So we're just listing out what are all the factors of 60, what numbers multiply to make that, and checking, do they add or subtract somehow? Can I combine them to make this bottom number? So 4, 15. Now we can fill in our box. So the inside of the box mostly matches what's already here, right? 5n squared, 12. These are both going to have an n in them or an x, right? If we're doing a problem with an x, it's just going to have a single value of our variable. And then the numbers we got, 4 and 15. Now, at first glance, it does not look like this is going to work. Sorry, heard bird noises. But we just have to factor out, we have to divide out the thing that is in common. What does a 5n squared and a 4n have in common? Well, not a lot, just a single n. Right, so we're going to fill in these spaces here. Just a single n. What does 4n and 12 have in common? Well, I can divide 12 by 4. I can divide this by 4. So 4. What does this row have in common? 5n squared and 15n. Both of those I can divide out a 5 and an n. Yeah, yeah, both of those. So don't forget the variable. These two top left numbers are always going to have a variable because n times n makes n squared, right? Yeah, so 5n squared. And so that makes this number need to be whatever 4 times something to make the 12 and whatever 5 times something to make the 15. So this has to be 3. And so that means this equals, let's use a different color, they're all kind of the same. That means this has to be 5n plus 4 times n plus 3. Okay. I need to find another one with a negative in it that we'll do next. Hopefully this process feels very step by step. I think the hardest parts are definitely figuring out two numbers that multiply to make the top number and add to make the bottom number. That's the first hard part. And then the second hard part is like figuring out what multiplies in each row and column, right? Let's see, something with a negative. Let's not do number 9. Let's do number 10. So number 10 from that PDF says 5x squared minus 18x plus 9. And we want to make that equal something times something else. We're going to factor it. Okay, so first step, list out A, B, and C. 5, negative 18, and a positive 9. And then we're going to use that to figure out what's in our x. So AC up here. You don't need to write A, C, and B every time, but if you can't remember that it's AC, A times C and B, then it's helpful to write this out. So 5 times 9 is 45, positive 45, right? And then negative 18 here. So what are numbers that make 45? That multiply to make 45? Because like a whole lot of numbers add to make negative 18. And so this is going to tell us our possible numbers. The numbers that multiply to make 45 tell us our possible numbers. Numbers multiply to make 45. Well, we can always start with 1 times the thing. In this case, it's not 1 times the thing. 9 and 5. Those add to make 14. Or subtract to make 4. Or negative, positive or negative, right? So right now I'm not concerned about figuring out if the values are positive or negative. I'm just figuring out what are their quantity. So right, Stephen said negative 9 and negative 5. That's smart. He's already thinking, well, they multiply to make a positive number and add to make a negative number. I think that's too big, Kyle. 6 times 12 is 72. Yeah, so that's why we do the top part first, because it's really easy to come up with numbers that add to make negative 18, but they got to multiply to make the 45. All right, so our next options, things that multiply to make 45, 3 and 15, right? 3 times 15. Those combine to make 18. They can add to make 18. So this is 3, and this is 15. 3 and 15. But they need to both be negative, right? We have to add up to this negative 18. So they're both negative. Two negatives multiplying make positive 45, and then when they add, they make negative 18. So now we can fill in our box. It looks different on my paper, but now I'm writing in orange. But on the screen, it looks like these are basically the same color. Oh well. So in this box, it's going to be 5x squared. In this box, it's going to be 9. And then these two boxes add to make the negative 18. Right, so one of them is negative 3x, and one of them is negative 15x. Did we do that right? Yep, we're good so far. It just doesn't look right, but it is. Those two numbers add to make the negative 18. Yep. All right, so then, what color should I use? Let's use blue. So then, what's a number I can factor out of 9 and 3x? Well, just they have a 3 in common. We're going to fill in these spots. They have a 3 in common. Not really concerned about the positive or negative part yet. Or we got to figure out how to get a negative here. But I'm not super concerned about that yet. What times 3 is going to give us 9? Well, this is also 3. And then what do we have in common with the 5x squared and the negative 15x? Well, those both have a 5 in them and an x in them. And then here, it doesn't look like there's a whole lot in common, but the x's are in common. There's an x squared and then there's an x. Now, this is not correct because we left out our negative pieces, right? So to get negative 15 here, this needs to be negative. And to get negative 3 here, this needs to be negative because when we multiply those two, it makes a positive 9. Okay, so then our answer is 5x minus 3, and x minus 3. Now, you could have said that these top two were negative and these were positive, and that's the same thing. It's the same. But we like to not have negatives on our x's and our 5x's. We like to put the negatives on these numbers. This is the same. You could have written negative 5x plus 3 and negative x plus 3, and that would give you the same thing. But you can always double check your work. We can always double check, are these blue numbers the right thing? Because all we have to do is multiply this back out and see if we get what we started with. Like if I multiply x times 5x, do I get 5x squared? Yep. X times negative 3, negative 3x. Negative 3 times 5x, negative 15x. And negative 3 times negative 3 is 9. So we got to double check. If we multiply it back, do we get the things that are inside the box? We got 2 minutes left. I don't think that's enough time for another example. I don't think that's enough time. So that's how you multiply, or that's how you factor using the Xbox method.